Hey friends, it's Mrs. Gregerson, and we are going on in Chapter 4. We're talking about triangle congruence, and we're going to get two theorems that saves us tons of time. In Lesson 4.1, we talked about how we had to show that all corresponding parts had to be congruent in order to prove, and we ended up doing like a 10-step proof. So we had to have 3 pairs of congruent angles, and we had to have 3 pairs of congruent sides. Well, the cool thing is with triangles, we should be able to find some shortcuts that would be able to help us. And the first thing that helps us do this is triangle rigidity. Rigid is of someone who's immovable. They only do one way, don't see other viewpoints. That's not always a good term. Or you can also say if something's rigid, it's real stiff, it won't bend. So basically, triangle rigidity means you can't change. This will always happen no matter what. And the property of triangle rigidity is the following. It states that if the side lengths of a triangle are given, then the triangle can only have one shape. Let me give you just a simple example. You can do this with pens, pencils, markers. I'm going to use paper clips. Okay, here I have 3 paper clips. They're going to represent 3 sides of a triangle. Now when I put them together to make a triangle, you can clearly see that shape. But what if I decide to move it around? You know, maybe I want to do it this way. If you notice, the triangle is exactly the same triangle. I can't change, or maybe if I put it this way, maybe, right? No matter what, I can't change the shape of that triangle. It might change orientation, which means I flip it or put it on its side, but no matter what, that triangle ends up being the same. So the cool thing is if I know side lengths, that helps me out a lot being able to prove triangles are congruent. And so we get our first theorem or postulate, here in this case it's a postulate, that shows how triangles are congruent. And it's called the side-side-side congruence. Guess what we're going to talk about? Sides. The 3 pairs of corresponding sides. We don't even have to mention angles. And here's what the postulate states. If 3 sides, make that a D there, of one triangle are congruent to 3 sides of another triangle, then the third sides are congruent. This is a really easy way to prove triangles congruent. Now it's just strictly using the sides. And the SSS kind of reminds us what we're looking for, side, side, sides. So we have 1 pair of congruent sides right here. We have AB and we have FD. Then we have here our sides of the same length. So there's our second pair. And then our sides of 6 centimeters, that's our third pair. So we have, and I always label it like this, side, side, side. I only do it on one triangle, but it lets me know that I've had all 3 pairs. So the triangles are congruent. But you still have to do the matchy-matchy game where we put everything together. So like here, A is opposite the 6, so that means the one that's opposite, the vertex opposite the 6, has to also be matching. So A and F go together. So then I go B, well B is opposite the 7, well what's opposite the 7 here? D. Then we have our C, which lands up with E. So we still have to state our congruence. Now remember, that's called a congruence statement. And that's a congruence statement between the 2 triangles, and you'll have to know how to do that for the test. Another thing you want to remember when you work with this is that adjacent triangles share a side. So if you can apply the reflexive property to get a pair of congruent parts. So I can always do this one. So here's an example. It's kind of like a mini proof where we don't have to do this as much. What do we know? Well, let's see what's given. We know segment AB is congruent to segment. If I go AB, I'm going to go DB. And they're matchy-matchy. Make sure I use correct notation. That's given. That's one pair of sides. And then we have segment AC is congruent to segment DC. That's also given. But now I need a third pair of sides. Well, anything is congruent to itself. So segment BC is congruent to segment BC by the reflexive property. So the cool thing with that is now we can say, okay, because segment BC is congruent to segment BC, we have 3 pairs of congruent sides. Now remember, side, side, side. So triangle ABC is congruent to triangle DBC by the side-side congruence postulate. All right? Now I want to make sure that we say the side-side-side congruence when you work with this, because we also use similarity later.